a new language, we're going to talk about the actual language of chemistry. So similar to other languages, we have symbols and characters that have a meaning in a chemical context. So what we should be able to do by the end of this is understand and interpret information in a chemical formula, which you guys probably saw some in biology. We should recognize elements by their symbol. Every element, as we discussed, has its own unique symbol. We should understand the different phases of matter, or physical states is another way of saying that, as indicated by a formula. We should be able to interpret a chemical reaction and write one. Also, we should be able to predict what one would observe if a chemical reaction was undertaken. Chemistry is communication. Now, this is stuff that you guys may already be well aware of, but each element is on the periodic table. I believe I passed out a copy of the periodic table to you guys. And okay, good. Each element is represented by one capital letter, like nitrogen right here. Symbol for nitrogen is N. Or one capital letter in a lowercase letter, like calcium is Ca. Yes, Connor? It's a metal. It's found in a lot of different things. It's very important to life. We'll see that. It's actually called an alkali earth metal. And it's a key component in your bone growth, as well as lots of other things in biological processes. So, sometimes, most of the time, your element will sound kind of, the symbol will be kind of like the name. So, for instance, nitrogen's N, calcium's Ca. But sometimes we have these other funny ones. Like potassium, the symbol is K. For its old name, for its ancient name, Calum. Iron is Fe for ferrum. Lead is Pb for plumbum. Those are the old Latin names for the elements. Gold is Au for aurum. Mercury is Ag for hydroargum. That's the old name. That meant liquid silver. I don't know if you guys have ever seen mercury. Most people haven't. They banned it from use as a metal. So anyway, that's some interesting things about symbols. So most of them are close to the name. Some of them you're going to need to take a look at the actual name on the periodic table. And I believe the periodic table actually has the names. So remember, chemistry is about communicating things. Symbols communicate the element. Every substance has its own formula. The formula gives certain information. It gives the elements present in the particle. You don't actually have to write down what's in parentheses here, guys. So don't worry about that. And the number of each element in the particle. Okay? So everybody look up here. I'll give you guys a second to copy this down momentarily. So, for example, a formula for potassium sulfate is K2SO4. And we can get a certain amount of information from that. We can get information that's made of potassium atoms, that's why there's a K, sulfur atoms, that's why there's an S, oxygen atoms, because that's why there's an O. So this here, K2SO4, is made of 2 potassium atoms, 1 sulfur atom, and 4 oxygen atoms. If there's no subscript written like there is an S right here, 1 is understood. And if you guys wanted to write K2S1O4, I would be perfectly fine with that. Okay? That's if you guys feel more comfortable doing that. All right? I'll give you guys a second. Here's another example. Hold on. Don't write down anything yet. I'll give you a second. So, Cu, parentheses, NO32. when we see something in parentheses, it's kind of like what we see in algebra. So if there's a 2 outside of parentheses in algebra, what does that mean? Connor? What's that? Not quite. But if I have a 2 outside the parentheses, that just means I have 2 of whatever's in the parentheses. That's what I was getting at. So, does that make sense? So that means I have 2 groups of this NO3 here. So, in NO3, just one NO3, there'd be one N and 3 O's. So NO32 means that there's 2 N's and 6 O's. So the entire compound is 1 Cu, 2 N's, and 6 O's. Moving forward. So you look at this formula, you guys should be able to recognize that there's one atom of copper, 2 atoms of nitrogen, and 6 atoms of oxygen. Okay? Moving on. So, in chemistry, we use symbols to represent chemicals and chemical reactions. Don't write anything yet. I'll let you know. So, there are a few symbols that we use to describe the phases of the matter. S is solid, L is liquid, G is gas, and AQ means aqueous solution. It's the chemical way of saying that something's dissolved in water.